Hello students, welcome back. We completed nearly everything from section 2 except for the last one here, sample size problem. What did he do in section 1, by the way, about the sample size? It was this problem, which I did not emphasize very much and made it into an optional video. Well, I'm not going to do that here in section 2 because it does pose some importance here for binomial proportions. This is basically related to pre-survey mathematical analysis. Before going out to a survey, we have to design it and then determine the sample size based upon what we want. In this particular case, we want the margin of error of plus or minus 2% point with the confidence level of 97%. Based upon that, determine the sample size, and then based upon that, design the survey, get the list of people, get the sample, go out and then find out, bring all those data back, and then with those survey data, we can do confidence interval, confidence bounds, those kind of things. All right, let's begin the pre-survey analysis. A political research team is preparing for an opinion poll of an upcoming referendum through a simple random testing. If they want to obtain the point estimate of the referendum within the margin of error of 2.0% point with a confidence level of 97%, what is the minimum number of sample size? All right, this is a normal problem, so we need a normal picture. Let's go here, and yeah, this one is for 95% confidence interval, and I want 97% confidence interval. All right, that looks better. Okay, here we go. Now, what is the expected proportion here? This problem did not say. But do we actually need it? No, not really. What is the margin of error? From here to there, this radius, this and this, that proportion, whatever it is, cancel out. We get this. The margin of error is z-score times the standard error. We established it in section 1, so we're going to use it. Now, what is the z-score for this? 97% in the middle, which means 1.5% to the left, 1.5% to the right. Actually, before that, I have to write one more, excuse me. Z-score times, what is standard error? It is P, 1 minus P over N. Okay, all right, we're going to start from here. So what is the margin of error for this problem? 2.0%? 2.0% point, 0.0020. No, that's 0.2% point. Okay, all right, that's right. That's what we want, isn't it? Now, what's the z-score associated to 97%? 1.5% here, 1.5% there. If you do it right, you're going to get 2.17 approximately speaking. Let's go to the normal table here, and you want left-hand side shading of 1.5%. Yeah, it's right here. Negative 2.17. This is 987. Negative 2.17, and then that's for the left-hand side. For the right-hand side, it is positive 2.17. Here, for the margin of error, we want positive value, so 2.17. Oh, by the way, okay, all right. Sorry about the typo. Now we have this. And what's the quantity that we want? We want the sample size of n. Can you solve this equation? Well, we have a problem. N is an unknown variable that we want to find out. Great. And these two are numbers, so punching the calculator, we can get it done. But what is P? If the problem gave us the expected proportion of, say, for example, 75%, yeah, okay, I'm going to plug in 0.75 and go from there. But this problem did not give us anything. In that case, we have to use P equals to 0.5. Why 0.5? Because that's the safest. That's when the margin of error is the greatest. Look at this expression, P times 1 minus P. And please note that this is a quadratic expression. And proportion is always between 0 and 1. So if I plot that expression, what do I see? I have a quadratic picture, the parabolic picture here, and hits the maximum at 0.5. Do you see it? You don't need calculus for that. This is just intermediate algebra. So the maximum error takes place at 0.5. So that's why I'm plugging in P equals to 0.5. So that's the strategy. Margin of error given, z-score you can look up. The proportion 0.5 unless it is explicitly given from the problem. If the problem gave you to use 40%, then use 0.4 and 1 minus 0.4. If the problem gave you 75%, plug in 0.75 and 1 minus 0.75. Otherwise, you're going to use 0.5. The reason I just showed you, the maximum takes place at 0.5. It's parabolic expression. Okay, all right, we have an equation to solve, so let's solve it. How do you do that? First, flip this to the other side. Yeah, algebraic manipulation, just division. So dividing by 2.17. Is that clear to everybody? Okay, next. The square root. I'm going to get out of the square root. So how do I do that? I take the square. Square both sides. Then what do I get? We lose the square root in the right hand side. Okay, next what I do? Well, the quantity I want is down there. So we actually exchange these two. This one and that one. What am I talking about? This one comes down here. And then this one becomes n. Let me expand the font here. Do you get it? Do you understand this? Maybe not. Okay, for those students, let me slow down. Here in this expression, multiply both sides by n. Multiply by n. And then multiply by n. So multiply both sides by n, but here we have this multiplication by n, and then n that was down there before cancel each other out and they just go away. And then I have to remove this, so divide both of those by this quantity. Too many fractions, so let me expand the font. And then this multiplication and the division cancel each other out, so they go away. And what's left is this one and that one changing place. All right, so far so good. So let's punch this into calculator. It's just a calculator work, and if you do it right, I'm getting this quantity. Something's not right. Oh yeah. Sorry about that. There was a bit of a typo. 2.17. I ended up typing 2.71. Sorry about that. Okay, all right. That's the number I'm supposed to get. Okay, so about this is right. And then we want to be a little bit safer, so you have to round up. So I can conclude as about 2,944. But then again, come on, we are talking about large number, so this probably is not the best expression or best rounding. I would much rather do it this way. About 3,000, or about 3,000 at least. Let's recap this. Here's a picture. I want the margin of error, the distance from the center to one of the endpoints, which is z times standard error. What is z? That's coming from the confidence level. You can always look up the z table. I'll leave the details to you about the z table. And then what is the margin of error? That's given from the problem. 2.0 percent point. So it is 0.02, and the z-score is 2.17. And here in this expression, square root of p1 minus p over n, plug in p as 0.5. All done. We have an equation to solve. Now, if you're really good at the algebra, then from here, it's your territory. Just go ahead and do that. But in 1000 level, many students struggle here. So let's take it step by step. Let's remove this number so that isolate square root. All right, divide by that. Okay, we get that. And you can punch in the calculator, which I did in this notebook, by the way, but most of the time I postpone it as much as possible. And then square both sides to remove the square root. Okay, I have it here. Again, you can calculate this one if you want to, but as I said before, I usually postpone everything until the very end. Now, how to find this one out? This kind of thing happens a lot, so it's going to be a good idea to remember this. If some quantity equals a fraction, then you can exchange this denominator and that. And I explained why that is taking place, right? Even if you don't remember, this is a neat trick. And then, of course, now right inside is all numbers, so just punch in the calculator. 2,900 something. So roughly speaking, 3,000 or more will do. But as a matter of fact, this is just mathematics. In reality, it has to be significantly more than 3,000 because you have to count in non-responders. And the ratio of non-responders vary tremendously between one neighborhood to another and one type of survey to another, one type of political issue over another. So you have to have some historical value for that so that, based upon past history about this issue around here in this neighborhood, if I want 3,000, then multiply by 1.5 and then interview 4,500 people so that you lose a lot of non-responders, still come up with 3,000. You do those kind of things. In any case, as far as the mathematics is concerned, it works like this. And then in the end, you round up. Okay, what did I do in my notebook? Pretty much the same thing. This is essentially the same picture. Yeah, this picture. And then the solution here, same equation, except that this time here in my notebook, at each step, I calculated. SE, like this, and then 0.020 over 2.17, I calculated. So we get the square root equals to that. And square both sides, I calculated that square. And then exchange this on that and calculate it. In the end, I ended up with 2,943. So on the safe side, about 3,000 people. The same as before.